Hello, listeners! This is Federica
and Alexandra from Drug Safety Matters.
Before we resume our episode, we wanted to announce a new podcast feature. It's called Fan Mail, and it makes it even easier for you to get in touch with us.
That's right. All you have to do is click the link at the top of this episode's show notes. That will open a new text message directly to the show.
All text messages are anonymous and will be sent to our podcast platform. You can use this feature to ask us questions,
suggest new topics,
or just say hi.
We can't wait to hear from you. Now on with the show.
Welcome to Drug Safety Matters, a podcast by Uppsala Monitoring Center, where we explore current issues in pharmacovigilance and patient safety. My name is Federica Santoro, and this episode is part of the Uppsala Reports Long Reads series, where we select the most topical stories from our magazine, Uppsala Reports, and bring them to you in audio format. Our pick for today is the article Africa Integral to Evolution of Pharmacogenomics Research, which appeared online in October 2020 and in print in issue 83 of the magazine. As the cradle of modern humanity, the African continent is home to populations with high levels of genetic diversity. This diversity has implications for the safety and efficacy of many drugs, but sadly, African patients remain underrepresented in drug studies. In fact, of more than 400 medicines with pharmacogenetics information and public guidelines available, only 15 have been studied in African populations. Thankfully, efforts to boost pharmacogenomics research in Africa are now underway. Here's the full story, written by scientific writer Alexandra Coutinho. Although populations living in Africa make up 10% of the world population, Africa carries 25% of the global disease burden. Infectious diseases, such as malaria, HIV, and tuberculosis, are leading causes of mortality in Africa. And due to changes to a more Western lifestyle, non-communicable diseases, such as cardiovascular disease, are increasingly contributing to the disease burden. The use of medicines such as antiretroviral drugs to treat infectious diseases has had both positive and negative consequences for African patients. While their use has contributed to an increase in recovery rates and an overall reduction in mortality from these diseases, it has also caused an increase in the incidence of adverse drug reactions in hospitals. In fact, 80% of recorded adverse events in Africa are due to antiretrovirals, and adverse drug reactions are 5 to 10% higher in African populations than in the rest of the world. HIV is one of the leading causes of death in Africa and is treated using antiretroviral drugs such as efavirenz and dolutegravir. However, these drugs may be harmful depending on how the body metabolizes them. So it is important to determine the correct dosage for effective treatment with minimum side effects. And this is where genetic variation complicates the picture. Efavirenz is metabolized in the liver by a genetically polymorphic drug metabolizing enzyme called CYP2B6. The frequencies of the CYP2B6 G516T genotype, which is associated with blood plasma efavirenz concentration in non-African populations, have been used to calculate the optimal treatment dosage for this drug. While this dosage calculation method is effective for other world populations, studies on efavirenz in African populations found that 50% of African patients had efavirenz concentrations above that of the minimum toxic threshold. Dr. Afef Lamzouri, a medical geneticist based at the Moroccan Pharmacovigilance Center, is also the deputy chair of the recently formed Pharmacogenomics Special Interest Group within the International Society of Pharmacovigilance. She explains that the importance of another gene, CYP2D6, is also hard to overstate. CYP2D6 is responsible for the metabolism of approximately 25% of all drugs, and other CYP2D6 genetic variants in African patients may explain several cases of resistance or toxicity to other drugs, such as codeine and antidepressants, Lamzouri says. The drug isoniazid may also cause more harm in African patients. Isoniazid is used as a treatment for tuberculosis, another of the deadliest diseases affecting Africans, but is also associated with liver toxicity due to variation in the gene coding for the drug metabolizing enzyme N-acetyltransferase 2, or NAT2. Genetic variation in NAT2 is classed into 3 types of enzymes based on the speed with which they metabolize drugs: slow, intermediate, and fast acetylators. Patients with a slow NAT2 genotype are at high risk of developing toxicity to isoniazid. Studies investigating the frequency of this genotype in Moroccan patients, for example, have found that over 70% have the slow acetylator NAT2 genotype and are therefore far more sensitive to lower doses of isoniazid, Lamzouri says, adding that such findings highlight the urgency for the development of genotype-guided dosing specifically for African populations. In non-communicable diseases too, pharmacogenomic factors can be important considerations in determining effective drug dosage. For example, warfarin, an anticoagulant, is one of the main medications used to treat cardiovascular disease. A patient's response to warfarin, and therefore its dosage, is highly dependent on certain genetic markers, the most notable being the CYP2C9 and VCORC1 genes. Yet, as Africans have the highest genetic diversity of all world populations, research has found that the typical genetic markers used to gauge warfarin dosage and response in other world populations are not so effective when applied to African populations. This is also the case between different ethnic groups within the African continent. In the Moroccan Pharmacovigilance Center, we receive a lot of notifications regarding serious drug eruptions or skin reactions from medicines such as antiepileptics and allopurinol, and many African countries report the same high frequency of these drug eruptions. It is imperative to carry out pharmacogenomics studies to explain this high prevalence in African populations compared to other populations, Lamzouri says. And here we come to the crux of the problem. Despite Africans being the most genetically diverse humans in the world, they are also the most understudied populations in the world. A study exploring drug metabolizing enzyme genes across the world found that African populations show greater genetic diversity than the rest of the world's populations. But the extent of this pharmacogenetic variation in African populations is unknown. And of the more than 400 medicines with available pharmacogenetics information and public guidelines, only 15 have been studied in African populations, of which there is an average of only 1 to 3 studies available on each one for the whole continent, comprising 54 countries. This dearth of research has huge implications, not only for the successful treatment of disease in Africa, but for pharmacogenomics knowledge in general. As modern humans first evolved in Africa, the discovery of genetic markers involved in drug response in African populations could be incredibly valuable for the rest of the world. Pharmacogenomics research in Africa has been restricted by a lack of funding, education in pharmacology and personalized medicine, and the limited capacity of many clinical practices on the continent. Nevertheless, different initiatives have been started over the last decade to rectify these issues. The H3 Africa and Malaria Gen projects were established to study genetic variation related to disease susceptibility in African populations. Although they are not directly involved in pharmacogenomics, these projects have already increased the understanding of pharmacogenetic variants in African populations and have increased the amount of African genetic data available for pharmacogenomics research. One of the most important initiatives to date has been the creation of the African Pharmacogenomics Consortium, or APC, in 2018. The APC is led by Professor Kolle Dandara, a principal investigator of the Pharmacogenomics and Drug Metabolism Research Group at the University of Cape Town, to drive pharmacogenomics research in Africa and improve the safety of drugs for use in African populations. The APC plans to raise awareness of pharmacogenomics among Africans and train African researchers and clinicians to carry out clinical trials in African populations and conduct more of their own research into pharmacogenomics in Africa. The consortium also aims to increase the capacity for pharmacogenomics in Africa by developing biobanks and repositories to support pharmacogenomics research, as well as implementing better systems where genetic data may be stored, shared, and used in collaborations between African and international researchers. Likewise, the Global Alliance for Genomics and Health aims to enable the safe and effective sharing of genomic and health-related data between different research and healthcare institutions, and its formation has been identified by other lead African pharmacogenomics researchers as another important milestone on Africa's path to personalized medicine. There is a long road ahead for African pharmacogenomics to catch up to that of the rest of the world, but its researchers are rising to the challenge. With the recent formation of initiatives like the APC, the future may hold some exciting discoveries that will propagate the entire pharmacogenomics field. Most importantly, a boost in pharmacogenomics research in Africa will improve the treatment outcome for millions of Africans suffering from infectious and non-communicable diseases, so that Africa will no longer carry a quarter of the world's disease burden. That's all for now, but we'll be back soon with more long reads, as well as our usual conversations with medicine safety experts. If you'd like to know more, check out the episode's show notes or visit uppsalareports.org. If you'd like pharmacovigilance stories like this one delivered straight to your inbox every month, sign up for our free newsletter at uppsalareports.org/subscribe. If you like Drug Safety Matters, subscribe to it in your favorite podcast player and leave us a review so other listeners can find us. You can send any comments or suggestions for the show on social media. Look for Uppsala Monitoring Center on Facebook, LinkedIn, or Twitter and connect to us there. For Drug Safety Matters, I'm Federica Santoro. I'd like to thank Matthew Barwick for post-production support and you for listening. Till next time.